Welcome to the multivariable calculus section. In this section we'll be discussing motion in space, velocity and acceleration. So let's say you're an aspiring computer scientist hoping to develop games. As an example, the previous game of ball hula hoop, in order to create a hula hoop object, we must use a parametric vector function to emulate the shape of a hoop. Additionally, in order for the ball object to most accurately align with the laws of physics, we must integrate and derive functions to simulate a ball's true movement. So let's delve into the motion of a space. Now, the rate of change of a vector function is equal to the velocity of said vector function. Additionally, the rate of change of the velocity of said vector function is equal to the acceleration of said vector function. Or more simply put, we can say that a of t, and we're going to put our vector, is equal to v prime of t is equal to r double prime of t. Now, additionally, we know that speed is given by the magnitude of our velocity. Therefore, we can determine the speed of an object at any given time. Now, if we wanted to represent where this ball was, we would use r of t for our vector function because it occupies a point in space and a direction that it's moving. Now, if we wanted to find the velocity, we would take the derivative of our vector function, and if we wanted to find the rate that it was accelerating at, we would take the derivative of our velocity function. Now, say we had the position vector r of t is equal to t to the fourth t cubed t squared. Now, this is not too bad, but we were asked to find the velocity and the acceleration at t equals 2. So we would take the derivative of the vector function, and that would give us the velocity. And we can say that it's 4t cubed, 3t squared, 2t. And we want to find the velocity at 2. So we'll plug in 2 to our equation. So we know 2 to the third is 8, so we have 32, we have 12, and we have 4. And that would be the velocity. It would be at 2 seconds, so it would be moving 32 meters per second in the x direction, 12 meters per second in the y direction, and 4 meters per second in the z direction. Now, if we wanted to find the acceleration, we take the derivative of our velocity vector function, and we would say that this is equal to 12t squared, 6t, and 2. So that means it would always accelerate at 2 meters per second in the z-axis, but we would plug in a of 2 in order to figure out the rest of the components. So we know that 2 squared is going to be 4, so it's going to be 48, 12, and 2, which means that this is going to be traveling at 48 meters a second squared in the x direction, 12 meters a second squared in the y direction, and 2 meters a second squared in the z direction. That's a pretty fast basketball. Okay, so I hope that helps, and there's a bunch of additional information on the website. Thank you.